Hey everyone, welcome to this explainer. Today we're going on an absolute thrill ride. We are going to visually explore the epic, entirely invisible transport system that is literally keeping you alive at this very second. You know, we so often take our bodies for granted, but what's happening just under our skin is nothing short of an anatomical masterpiece. Today, we're tracing the ultimate micro-hero's journey, the path of a single breath of air and the relentless circulatory system that carries it to the absolute furthest reaches of your body.
Okay, let's dive right into this. I want you to do something for me. Literally, just take one deep breath. Right now. Go ahead. Inhale and exhale. That felt pretty simple, right? Completely effortless. But in those few seconds, you just kicked off a high-speed, microscopic logistics operation that involves hundreds of millions of delicate structures, a massive vascular highway, and a tireless biological engine. Let's break down exactly what just happened.
All right, Section 1, the breath's beginning. Let's see how air enters the body.
So we're starting our journey right where the outside world actually meets the inside of your body. Prepare for a seriously rapid descent. As you breathe in, that oxygen-rich air acts like a roller coaster car just dropping into a tunnel. It sweeps into your nose, rushes through the nasal passages, and plunges right past the pharynx and larynx. From there, it shoots down your main windpipe, the trachea. But this tunnel doesn't just go straight down, right? It begins to branch out, kind of like an upside-down tree. The air splits into the main bronchi, those are the large airways of the lungs, and then races into an ever-narrowing maze of smaller and smaller tubes called the bronchioles. The speed and precision here are just absolutely mind-blowing.
And then, suddenly, bam! This high-speed descent just comes to an end. The narrow bronchioles open up into these tiny, incredibly fragile sacs called alveoli. Notice how they look almost like microscopic clusters of grapes? Well, this is ground zero. This is the critical location where the air you just breathed in finally meets your bloodstream.
Moving on to Section 2, the tennis court inside. Let's talk about alveolar surface area.
To truly appreciate what happens inside the lungs, we have to talk about scale. Because biology has this brilliant way of fitting massive potential into really tiny spaces. Just look at this number, 600 to 800 million. That is the sheer volume of these alveolar sacs packed inside the human lungs. It's a staggering, astronomical figure. But why do we need so many of these fragile little structures?
And this brilliantly illustrates exactly why. If you were to take all 600 to 800 million of those microscopic alveolar sacs and flatten them out side by side, their total surface area would be around 100 square meters. That is the size of an entire tennis court, folded up and tucked neatly inside your chest. No way, right? The reason your body does this is just pure engineering genius. By maximizing that surface area, which is richly lined with tiny blood vessels, your lungs can pull in the maximum amount of oxygen in literally a fraction of a second. Now, what's super interesting here is the swap itself. The walls of these alveoli are lined with ultra-thin blood vessels called capillaries. Right here, across this massive, microscopically thin barrier, a vital trade goes down. Oxygen abandons the air and crosses over into the blood. At the exact same microsecond, carbon dioxide, which is a waste product floating around in your blood, escapes into the air inside your lungs.
Okay, Section 3, the heart's mighty pump. Let's see how this blood gets moving.
So, we've captured the oxygen. But honestly, just sitting in the lungs doesn't do our body any good. It needs to move. And this is where the true power of our cardiovascular system takes over. The blood that initially arrived at the alveoli was depleted, totally exhausted of its oxygen. But now it is deeply enriched. This freshly oxygenated blood immediately departs the lungs, speeding through the pulmonary vein. It is on a direct collision course with the powerhouse of your entire body.
So the crucial point to remember here is that the heart is literally acting as a pump. I know it sounds incredibly simple, but the mechanical power of the human heart is staggering. When that oxygen-rich blood pours into the heart, this muscular engine forcefully contracts, violently propelling the blood outward. It's the ultimate biological pressure system, taking the precious cargo from the lungs and launching it onto the body's vast highway.
The mission here is critical. The heart's relentless pumping pushes this high-speed transport fleet of blood through the entire vascular system. The target? Every single organ in your body. Your brain, your liver, your muscles, your skin, absolutely none of them can survive without a constant, uninterrupted supply of this oxygen. And it's that combined, flawless teamwork of the blood acting as the delivery vehicle and the heart acting as the engine that makes life possible.
Which brings us to Section 4, the cellular exchange, the final destination.
So we've traveled from the open air, down to the lungs, into the blood, through the mighty heart, and out into the body. Now we're zooming all the way in to the final destination, the ultimate two-way courier system at the cellular level. When the oxygen-rich blood arrives at your working organs, it doesn't just do a quick drop-off. It's a fully dual operation. During the delivery phase, the blood hands over that precious oxygen necessary for cellular metabolism, its literal fuel for the cell. Meanwhile, during the retrieval phase, as these cells breathe and consume that oxygen, they generate a toxic waste product, carbon dioxide. The blood instantly collects this CO2. It's a perfect simultaneous exchange. Fuel delivered, trash collected.
Let's move to and see how this builds right back to where we started. The exact moment the blood grabs that CO2 waste, it pivots. The blood vessels act as a one-way street rushing back toward the center of the body. Driven by the continuous, tireless pumping of the heart, this dark, depleted, CO2-heavy blood speeds all the way back to the lungs, straight back to those tiny alveolar sacs.
And just like that, here we are, right back at the tennis court. The CO2 is extracted from the blood, pushed across that ultra-thin capillary wall, and dumped into the lung cavity. And as your chest compresses, you exhale. That carbon dioxide is violently expelled through your bronchi, up your trachea, past your larynx, and out of your nose and mouth back into the atmosphere. The problem is solved. The cycle is completely finished. Which leaves us with this final, kind of crazy thought. Think about the incredible complexity, the speed, the massive surface area, and the relentless pumping engine required for just that one breath you took earlier. So what does this all mean? Well, how many times will this epic, microscopic transport cycle happen inside you today? Roughly 20,000 times, every single day. You are a walking, breathing marvel of microscopic engineering. Thank you so much for diving into this explainer with me. Keep learning, and hey, don't forget to appreciate